Determine whether the following systems represented by input-output relations are time invariant and invertible. Here two systems are given. We are supposed to verify whether the systems are time invariant and invertible. Let me consider the first system, that is y of t is equal to x of t by 2. This is the given system. First we will check the condition for time invariant, that is time invariant property. Time invariant property says that the shift in the input should produce the identical shift in the output. Now I will explain. Let me take the system having operator h. Suppose the input x of t is applied to the system. It produces output y of t, which is equal to x of t by 2. It means that this system will provide a time scaling, and the time scaling factor is 1 by 2, that is 0.5. Now I will pass this through the delay element or delay system. This is the delay system, provides a delay of t0 unit. Then the output of this delay system will be replace each t by t minus t0. I can get it as y of t minus t0 will be equal to x of t minus t0 divided by 2. So we have shifted the output signal by t0 unit. Now I will apply the delay in the input signal. First I will apply delay in the input signal. Delay by t0 unit. Say this is x of t. The output will be x of t minus t0 because it's a delay system. Now I will pass through the same system having operator h. The characteristic of this system is it provides the time scaling. So here I will call the output of this as, say, y of t will be equal to x of. So here we can see that this system will replace the t by t by 2. Similarly, here also the system will replace t by t by 2. So I can represent it as replace each t by t by 2, that is t by 2 minus t0. I will call it as 1, I will call it as 2. So here if 1 is equal to 2, then we can say that the system is time invariant. But in this case 1 is not equal to 2, therefore system is time variant. Or we can also say that, or it is not time invariant system. Now we'll check whether this system is invertible or not. Invertible. Here the system is said to be invertible if input to the system is recovered from the output of the system. That is, here we know that the given system is y of t is equal to x of t by 2. That is, say this is my system having system operator, say h of something. The input to the system is x of t and it produces output y of t is equal to x of t by 2. It means that this system will replace t by 2, so that we'll get the output as y of t is equal to x of t by 2. Now I should use another system such that if I apply input to that system output should produce back the same input, that is x of t. So now I will try to pass this through another system. That system I will call it as inverse system. I will represent it as H inverse. If I pass this input through this system, I should get back the same signal x of t. So here if I use the system operator as 2t, that is replace each t by 2t, I will get the output as x of 2t by 2, which is same as x of t. So therefore now I can say the input to the system was x of t and I revert back the same signal, that is x of t. Therefore this system is invertible. This is how we now let me consider the second system, that is y of t is equal to integration minus infinity to t x of tau d tau. First I will check for time invariant. So as I discussed already, first I will pass the signal through a system, that is, say this is the system having system operator h. The input to the system is say x of t, which produces output as y of t is equal to integration minus infinity to t x of tau d tau. It means this will provide the integration of the input signal. Now I will pass this signal through the delay element. Through the delay system provides a delay of t naught. In that case, each t is replaced by t naught. So output of this will be y of t is replaced by t minus t naught, that is still delayed by t naught unit, is equal to integration minus infinity to t is nothing but t minus t naught x of tau d tau. I will call it as equation 1. So here we have provided shift in the output signal. So now we'll provide shift in the input signal first. That is, we'll try to swap these two systems. First, I will use the delay element or delay system. That is delay system delayed by t naught unit. The input to the system is say x of t. The output will be x of t minus t naught. Now I will pass through the same system which will provide the integration. That is, I will use the same system having operator same, that is h, which provides the output will be, say I will call it as y1 of t, which is nothing but h of x of t minus t naught, which will be equal to integration minus infinity to t. We have x of tau minus t naught d tau. This is the nature of this system which has provided this. Now we will try to simplify this. That is, y1 of t is equal to, here we have integration minus infinity to t x of tau minus t naught d tau. For simplification, I will put L is equal to tau minus t naught. So I will try to replace tau minus t naught by another variable, say L. So in this case, when here the variable is tau, when tau is equal to minus infinity, then L will be equal to, that is minus tau minus t naught, which is nothing but minus infinity. Similarly, when upper limit tau is equal to t, then this L will be equal to t minus t naught. T minus t naught. Now I will rewrite this y1 of t as y1 of t is equal to integration. We have lower limit is minus infinity to t minus t naught. Minus infinity to t minus t naught. We have x of L. So here, so dl will be equal to d tau. So therefore, x of tau minus t naught is nothing but L, and d tau is nothing but dl. That is dl. I will call it as equation 2. Now if I compare equation 1, which is minus infinity to t minus t naught equal to x of tau d tau, here it is minus infinity to t minus tau x of L t L. Here variable is L, here variable is tau. Therefore both are same. So we can say that y of t minus t naught is equal to h of x of t minus t naught. Therefore this system is time invariant system. So here 1 is equal to 2, therefore system is time invariant. Now we'll check whether it is invertible or not. System is invertible. Invertible. So here we have a system having system operator h. The input to the system is x of t. It produces the output as integration. Y of t is equal to integration minus infinity to t x of tau d tau. It means the function of this system is, it will provide integration. Now the thing is, now we are supposed to use the another system such that it should produce the same input, that is x of t. So if I pass through the another system, I will call that another system as inverse system. So if I pass through this signal through this system, it should give back the same signal, that is x of t. This is possible only when this system provides the differentiation, that is d by dt. So the integration and differentiation will get cancelled. The output of this system will be x of t. So therefore this system is invertible. And here invertible system is d by dt, that is differentiation. Thank you for watching.